Okay, well, you spent the last 7 weeks with me, and you know that I'm not someone that's happy with just saying, oh, the data is all in there in Chroma. We've got to look at this. So next, we're going to visualize, of course, the vectors in Chroma. And if you try and visualize all of them, all 800,000, then that's a sure way to crash your computer. So I don't recommend doing that. I tried doing that last year with like 400,000, and I just barely scraped by. So we're not going to do that. We're going to sub-select 10,000 points, and then we're going to load in those 10,000 points. And we're going to use t-SNE again, T-Distributed Stochastic Neighbor Embedding, to project down the 384 dimensions that the encoder came up with down to 2 dimensions and display that in some sort of a diagram. And so let's do that now. Let's create the 2D plot, and bam, here it is. And wow, isn't this cool? It reminds me of what we did in week 5, only just better. So this is 10,000 points shown visually in space, so we can understand what does it mean to take descriptions of products and put them in vectors. And again, remember the same point as week 5. The text that was given to the encoder did not include whereabouts in Amazon it was scraped from. We just gave it the text, and it turned that into a vector point. And after the fact, I've colored in these dots to represent what section in Amazon did this come from. But that information was not given to the encoder. So it's kind of cool that the different types of item are shown in different sections here. It shows that the encoder model had some kind of an innate understanding of the different types of things. Now, you might notice a subtlety here, that there is a category included in the text, because we actually, when we did our pre-processing, we asked an LLM, and in my case, I asked OSS 20 to come up with to turn just the vanilla text into something that had a category in it. Just keep in mind, that didn't come from Amazon. That wasn't information that got from which section of Amazon we went to. That was something that was put in there after the fact. So that's still something that's cool to see how that's allowed it to separate out different kinds of things. So for example, the stuff in blue here, this represents car parts, automotive stuff. And the stuff in red is toys and games. And maybe you're thinking, hang on a second, Ed, hang on, hold your horses. I see that there are red items in the middle of the blue stuff. That doesn't sound good. Well, if you take a look at that, you will find that they are in fact car parts of toy car parts. And the encoder model decided that this, even though it turns out on Amazon they were in a different section, the encoder thinks when it comes to the sort of meaning of things, it wants to put them around this territory, and that is up to the encoder. That's what it does, and that's how it's done it. And I take such great delight in exploring the data, in looking at what's ended up where, and understanding it in terms of the content of the text. And so I do encourage you to do the same thing. Spend a while digging into this, look at what's ended up where, get a sense for how the encoder is deciding where to put things. All of this is, of course, stored in Chroma, the free open source vector data store, but the vectors were determined by our encoder model, the All-Mini LM v6 L2 from Hugging Face. And you know me too well. You know I'm going to go and do a 3D plot next, obviously. Let's see how it looks in 3D. And just like in week 5, if you remember all the way back then, at first blush, it looks like a bit of a mess here. We've got like tons of stuff. But again, we can zoom in, which is always a great experience. Here it is. And we can rotate it around, and we can get this amazing sense of how the reds and the blues for the toy car parts are intermingled here. And you just get this much more visual sense of everything. So I do encourage you, spend some time with it. This is a really interesting way to dig into the data. It gets me very overexcited because it's super interesting, and it's also really cool. A great way to get that first-hand appreciation for what does it mean to take some text and turn it into a vector. Okay, enough with our diagrams. I never have enough with our diagrams. Let's do some turning this now into finding similar products into a RAG flow. Let's remind ourselves, what is our first test item in our test data set. Do you remember the first test item in the first test data set? Of course you do. It's the old blood noise distortion pedal, that guitar pedal that we all need. So I'm going to start by giving you a function called vector, which takes an item and it turns it into a vector. It does that by calling the encoder.encode. Okay, that's easy enough. You get that. All right. Well, just very easy as well is something called find similars. Given an item, this is going to return some similar items and their prices. And it's super simple. We just make a vector out of items. So we call this function here vector. And then we say collection. This is our Chroma collection dot query. And we pass in the vector. We've got something there fancy to turn like the NumPy array into a list. And we ask for 5 results back. We get the documents, we get the prices, and we return it. Okay, so what do I get if I do find similars for the distortion pedal? What do I get? Okay, I get these 5 responses. We get something also from old blood noise, but it's not a distortion pedal. It's an Endeavor's procession reverb. So a similar kind of audio effect box coming from the same manufacturer, but not the same one. We get a Boss MD2 mega distortion. So this is like another kind of distortion pedal from a different manufacturer. We get another old blood noise one that is a delay pedal, a different kind of effect, but from the same brand, and then a couple of other things. And here are the prices of those 5 things. So you can see immediately that we've got here similar products with their prices. This is working. It's all trivial, basically. We're just doing a vector lookup in a data store. And this is RAG at its core. This is saying, I've got something, I want to look up similar information to it because I'm going to shove that in my prompt. And in fact, that is exactly what we do in this next function. Make context, given something similar and some prices. So I'm going to have a message. For context, here are some other items that might be similar to the item you need to estimate. And then I'm just going to say potentially related product and list it out. Okay, so just to make that feel real for you, let's stick with our old blood noise distortion, whatever it is. Let's first find the things that are similar to it and then call this make context and see what that prints. So here we go. It says for context, here are some other items that might be similar. Potentially related, old blood noise, Endeavor's procession reverb. Potentially related product, Boss mega distortion pedal, and I've got the prices coming at the end here. So this is clearly a useful context, which a frontier model will be able to use to make a better price. So that feels like we're onto something here. And this is, of course, again, at the heart of RAG. Okay, and we can turn that into an OpenAI style messages with role user content message. And the message will be estimate the price of this product, respond with the price, no explanation, the same as before. And then there is the item summary. And then we're going to add in relevant examples. Okay, let's see this working. Estimate the price of the product. Let's again take the first test item and let's print the messages. Okay, we get role user content, estimate the price of this product, respond with the price, blah, 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 blah. It's exactly what we were expecting. Let's, instead of this, let's take this and take the 0th element of it and the content and print this so that we really see what we're getting. I need to close my brackets here, I think, and delete that. Let's run this. And this is what we get. Estimate the price of this product, respond with the price, no explanation. And there is the product. For context, here are some other items that might be similar to the item we need to estimate. And we have it. This seems super clear. And this is it. This is already our RAG pipeline. We can now have a function, GPT-5.1 RAG, where we simply take an item. Step 1, we find things that are similar to that item. Step 2, we call GPT-5.1. We pass in the messages that we build that looks just like this. And we don't need to do any reasoning. We're giving it all the information it needs. And that's it. That's all we need to do to be calling GPT-5.1 in RAG mode. You might have thought this is going to be super complex, and it's really not. We've just built a full RAG pipeline. The only thing that we remain to do is to try it out. Let's give it a shot.